So in this video I want to show you how to use the MolGraph library, which works with Keras to build machine learning models of graph convolution for molecules. So we'll start by installing MolGraph, and I'm going to do it for the GPU here. So it is important that if you haven't already done so, you change the run type here from CPU to GPU. And that is because it runs much faster on a GPU. As I'm recording this video, this only works on Google Colab for a particular version. So, but if that changes, then I'll leave some comments in the description of this video. So please check that if you're watching this video a few years from now. Okay, so let's get that installed. Okay, there are some warnings here, but despite these warnings, everything actually works fine. So don't worry about it right now. I'm going to use a data set that I've used in many other videos. I'm just going to paste it in here, but I'll leave a link, the link that I'm pasting in the video description. So it's the ESOL data set of molecular solubilities. So let's get that. Also, this works, as I'm recording this video again, this works on an older version of Keras than what we have here on Google Colab. So I'm going to change the environment here. To an older version, the legacy version. Here. Okay, and again, that might change in the future, and if so, I'll update the video description. So like before, we're gonna read in this file with Keras, with pandas. So I need to import pandas, like we usually do, as PD, and then read it in to a data frame. So let's grab that file. We have the data frame. So I'm going to have to turn these smiles molecules into mole objects and then into graphs, and then make the graph convolution here. So let me get rid of the data frame. So in order to do this, I'm going to use some features from the MolGraph library. So I need to import those so that they're in chemistry. Features, I need the featurizer, and I need the molecular encoder, graph encoder like this. Okay, so for these features here, I have a lot of options, and you can go to the MolGraph documentation and look at what the options are for features. But you can also get it here. And you can see there's all sorts of features. So I'm going to start with the most standard one, which is just the symbols. So what atoms are in the molecule. So for example, feature symbol. And then you can see it's just all the atoms here. and as I'll show you, they'll be Watthan encoded. The other feature, which I also talked about in the previous video, is hybridization. Right, so is the atom SP1, SP3D, SP3, SP2, or these kinds of hybridizations. So let's just start with these two. Right, so I'm going to have an atom encoder that I'm going to featureize the molecules with. So I'm going to use the featureizer. Oops. And yeah, I'm going to use the symbols and oops, and the hybridization. Like this. And is it not? Oh, it is symbol. Sorry. And did I spell that wrong as well? Hybridization. That needs to have brackets here as well. So then I can look at my auto encoder, and it's really just a concatenation of these two. Right, so I can also encode bonds, so the edges in the graph. And here, so let me just copy this. I'm just going to use the bond type, so double, single, triple, aromatic, and so forth. That's my bond encoder, and oh yeah, of course, you can't put hybridization on a bond. Great. And then I'm going to make my encoder out of these two encoders. So molecular graph encoder, and I'm going to have my atom encoder and my bond encoder, like so. Okay. And let me just show the bond encoder. I guess I didn't do that. Right, aromatic, double, single, triple, and so forth. Okay, so I'm going to turn the smiles in my data frame into these encoded representations. So I have my data here. Actually, let me just move that cell down. So I have my data read in, and let's just start with the y. That's the easiest, right? My y values is the measured solubilities. So they're here. And I'm going to just turn it into a list. And then, okay, so that's the y. The x then is my encoder of the smile strings. Here. And let me also make that into a list. So let us see what went wrong here. Oh, yeah, that's not the values. We want to make it into a list because those are obviously strings. Okay, and that takes a little while, but not too long. That should not have open brackets here. I keep forgetting that. Let's try that again. Okay, great. So, yeah. let me show you how one of these molecules look like, and I'm just going to pick a simple one. So I happen to know that number 146 is very simple. So if you just look at this file string here, it is just methanol. So then let's look at the X, what the X value, or what you give the model, how does that look for this simple molecule. Okay, and so you can see here you have, okay, there's obviously two atoms in this molecule, the carbon and the oxygen. And if you go in, so the symbols are one hot encoded. That I know happens to be the position for the carbon. So if you don't believe me, you can look here at the atom encoder. So these are all alphabetical here, and if you count along, here's carbon. That's actually this position. The next one here is oxygen, which is all the way down here. Right, so you have a 1 here, and they're both single bonds, right? So, sorry, they're both sp3. So the third to last should be a 1, right? So that's also, there's also unspecified actually. So 0, so 1, 2, 3, 4. 1, 2, 3, 4. There's a 1 in both of these. And then you can see for the bonds, the hybridization is single, right? So that is the third position here in the bond encoder. 1, 2, 3, right? They're both single. There's one bond, but you have 2 arrays here, because you have the bond from the carbon to the oxygen, and you also have the bond from the oxygen to the carbon. And those are actually, potentially different things in this graph convolutional scheme. Okay, and so all the molecules are featurized like this. So now it's a matter of building the model, and so we need to import some stuff in order to do that. So MolGraph is sort of built on Keras. So there's going to be a mix here of MolGraph and Keras. So we need to import Keras, and we also need to import MolGraph. Okay, and then we're going to build a model, just like we've done before with Keras. All right, so model. Now we're going to build a sequential model. Oops. Just need my square brackets here. Oops. Right, and we're gonna make it look a little nicer, like this. Okay, so we need an input. There shouldn't be Keras here. So we need an input layer first. So let's start here, right? So Keras, that's handled by the Keras part. Right, so there's an input layer, and then rather than, that would typically just be a number, which is the dimension of the x value. So here we're going to have to do it a little differently because it's graph convolution. So this sort of tells it it's a little more complicated input. And now we're going to start with a graph convolutional layer. So that comes from MolGraph. If I could spell that. So that's the MolGraph layer. And there are several types of graph convolution. As you can see when you find the manual, we're going to use the sort of the most simplest one. like so. And then, so that's one layer. Then if you watch the previous video, you know that that generates sort of embedding vectors for each atom. And in order to get a molecular description, one way is to just take an average of all the atomic descriptions. So that's certainly the simplest way of doing it. So in MolGraph, that's called the readout, right? So you now taken from the connectivity matrix, you combined all the atomic and bond embeddings or descriptions that you see here, and now you're just going to take the mean. So in this particular case with 2 atoms, it's simply just, this plus this divided by 2. Okay, and then that is then fed into sort of a normal Keras layer. Right, so now we're using Keras instead of MolGraph here. And here I'm just going to pick a dense layer. Let's just arbitrarily pick 100 hidden nodes and a Relu activation function. And then I'm just going to use a simple model here, and I want to make a regression model. Right, so I'm just going to have the final output layer here with no activation function, right? And I'm just predicting one y value. Okay, so this is sort of a very, very simple molecular graph convolution model. Let's just see. Yep, we got some spelling mistakes here. Okay. Otherwise, it's fine. And then you're just going to do the normal compile. And I'm just going to, again, more or less arbitrarily pick a mean squared error. As the loss. And then just fit the model with my x and y. And here I used the whole data set. Of course, you should split this up into a training, validation, and test set, exactly like you've done with other Keras models. And I'm just going to run a few epochs just to make sure it's working. So let's see how that goes. Okay, that's fine. You can see the loss is still pretty big, so you probably have to run it longer. You also want to check the learning rate, all this sort of stuff. And you definitely also want to think about using more features. And again, I showed you what features are available with the dir function, but you can also look in the manual. And lastly, of course, this is just, as I talked about in the previous video, right, this is just one graph convolutional layer. If you want sort of the atoms to feel atoms further away, you can add an extra, or you can add as many layers as you want. So last time I talked about 2 layers, and you simply do that just by copying this line. So now the atoms feel not just their neighbors, but the neighbors of the neighbors. And you can see the loss is already a little bit lower. So of course, how many of these convolutional layers you have, how many dense layers you have, how you combine the atomic embeddings to get the molecular embeddings, all that stuff are hyperparameters that you need to work with.